Hello students, we will learn about metals and non-metals, basic properties, a few chemical reaction, physical properties of metals. How can we recognize metals, or how can we differentiate between metals and non-metals? They have got a shine, that is luster. If we study certain metals like aluminium, iron, copper, magnesium, we see that there are some physical properties that make them different from non-metals. Metals have got a shine on their surface. If we cut a metal like copper, we see that there is a shine, and this shine is called as luster. They are hard and durable, and that is why we have vessels to be made of metals. Bodies of aeroplane make use of alloys of aluminium, as they are hard, durable, and can withstand great amount of heat. Ductility. Well, you must have seen the wires in your home. They are either made of copper or aluminium. Usually they are made of copper. So metals like copper, iron, aluminium can be drawn into wires. You can see over here, there is a picture of a copper wire. Then we have got aluminium wire, and you can also see that jewelry is going to be made of metals, and hence the property of metals that can be drawn into wires. The ability of metals to be drawn into wires is called as ductility. Jewelry wires, gold is the most ductile metal. You can obtain 2 km of wire from 1 gram of gold. It is because of their malleability and ductility that metals can be used for making cooking vessels. Now, good conductor of heat. Sometimes we must have left a spoon made of metal in a pan which is kept on a stove. When we touch the spoon, it becomes hot. This is because the heat is conducted away from the vessel to the spoon. We can understand this by a small activity in which we have got a metal like wire which may be made of aluminium. It is clamped on a stand, as you can see in the figure. At the free end, we have a pin which is fixed with the wax onto the metal wire. The wire was then heated with a Bunsen burner, the flame of a Bunsen burner, and it was observed that after some time the wax melts and the pin falls down. This is because the metal is a good conductor of heat and conducts the heat towards the free end. This makes the wax to melt and the pin falls down. So metals conduct heat. The best conductors of heat are silver and copper. Lead and mercury are relatively poor conductors of heat. Now, conduction of electricity. Metals are good conductors of electricity. Metals are good conductors of electricity. This can be explained through an activity in which we need a battery, a bulb, and key, as well as the free ends which are going to be attached to the wire. The metal to be tested is placed between A and B as shown. The wires in our homes are coated with a rubber-like material which is known as a polyvinyl chloride PVC. This insulates the wires. Sonorous. This is also a physical property which will be shown by metals, and metals exhibit this. When metals are struck, they produce a ringing sound. Bells are made of metals. Now coming to non-metals. There are only a few non-metals as compared to metals. Some of the example of non-metals are carbon, sulfur, iodine, oxygen, hydrogen. The non-metals are either solids or gases, except bromine, which is a liquid. Non-metals are not as hard as metals. Exception, diamond is the hardest substance known. They are not malleable, neither are they ductile. They do not conduct heat as metals do. They do not conduct electricity. Exception is graphite. It conducts electricity. Now there are a few exceptions in metals and non-metals. All metals except mercury exist as solid at room temperature. Mercury is a liquid. Metals have high melting points except gallium and cesium. They have got very low melting points. These two metals melt even when they are kept on our palms. यानी हाथ की हथेली में भी अगर हम रख दें तो ये cesium and gallium आराम से melt कर जाते हैं. Iodine is a non-metal but yet it is lustrous. Carbon is a non-metal that can exist in different forms, that is allotropic forms. Each form is an allotrope. Diamond is an allotrope of carbon, which is the hardest substance known and has got a very high melting and boiling point. Graphite is another allotrope of carbon, which is a good conductor of electricity. Alkali metals, lithium, sodium, potassium are so soft that they can be cut with a knife. They've got low densities and low melting points. Now, what happens when metals are burnt in air? Metals combine with oxygen to form metal oxides. Metal and oxygen, metal oxide. When copper is heated in air, it combines with oxygen to form copper 2 oxide. Similarly, aluminium forms aluminium oxide. Copper oxide reacts with hydrochloric acid to form copper chloride and water. Metallic oxides are basic in nature, but there are certain metallic oxides which are amphoteric in nature, that is, they exhibit both acidic and basic behavior. Examples: Al2O3 is amphoteric, it reacts with both a base and an acid to form salt and water. See over here, aluminium oxide is acting as a base because it reacts with an acid to form aluminium chloride and water. Aluminium chloride is a salt. Aluminium oxide also behaves like an acid when it reacts with a base like sodium hydroxide to form salt and water, sodium aluminate and water. Therefore, aluminium oxide is amphoteric in nature, since it behaves both as like an acid and a base. Similarly, we have got for zinc oxide and lead oxide. Zinc oxide is also amphoteric in nature. It reacts with an acid and it forms salt and water, that is zinc chloride and water. On the other hand, zinc oxide behaves like an acid when it reacts with a base to form sodium zincate and water. Sodium zincate is a salt. So most metal oxides are insoluble in water, but some of these dissolve in water to form alkalis. Sodium oxide, potassium oxide dissolve in water to form alkalis. All metals do not react with oxygen at the same rate. Potassium, sodium react vigorously with oxygen that they catch fire if they are kept open. Hence, to protect them and to prevent accidental fires, they are immersed in kerosene, means they are dipped in kerosene. At ordinary temperature, the surfaces of metals like magnesium, aluminium, zinc, lead are covered with a thin layer of oxide. The protective oxide layer prevents the metal from further oxidation. Iron does not burn on heating, but when iron fillings are sprinkled in the flame of burner, they burn. यानी जब हम आयरन को वैसे जलाते हैं, हीट करते हैं, तो वो जलता नहीं है. बट अगर हम आयरन फाइलिंग्स उनको फ्लेम में फेंक दें तो ये जलने लग जाते हैं. Copper does not burn, but the hot metal is coated with a black colored layer of copper oxide. Silver and gold do not react even at high temperatures. Anodizing is a process of forming a thick layer of aluminium. Aluminium develops a thin oxide layer when exposed to air. The aluminium oxide coat makes it resistant to further corrosion. The resistance can be improved further by making the oxide layer thicker. During anodizing, a clean aluminium article is made the anode and is electrolyzed with dilute sulfuric acid. The oxygen evolved at the anode reacts with aluminium to make a thicker protective oxide layer. The oxide layer can be dyed easily to give articles an attractive finish. Thanks a lot.